Been a lot of projects, dude. A lot of projects. Getting to the end of a lot of R&D and finishing up a lot of the other testing that we did. So production's full rolling. Just finished getting a big material order to keep all the stuff going. Actually stocking up for the big and final release for the intake manifold line, which a lot of guys have been waiting on. A couple guys know about it, but most of you guys didn't really know. That's what I've been doing the last few months. A lot of testing. Obviously, the last time out, we were over at EIC. Gabby was kind enough to lend me a bunch of his time and allocation, which, I mean, he's always busy. Incredible guy, incredible work, incredible shop. But he actually helped finalize the R&D process related to testing of the runner design, plenum shapes, plenum volume, stack heights, a lot of stuff. We were able to actually use a bunch of the 3D printed stuff, so we didn't have to machine stuff, because I really didn't want to go about just throwing something at the wall and hoping that it worked, because the way how I feel right now in most of these builds on the intake manifolds, I mean, turbo tech has advanced so much, engine management has advanced so much, transmission gearing, component strength has advanced so much. What's happening is guys are going fast regardless of what they really have, because these other aspects are getting a lot more efficient. And believe it or not, a lot of the designs that are out there when it comes to intake manifolds have been out there for a good while. So I figured it's like, if I decided to go that route, I had to really bring my A game and figure out something that would just be efficient, so that, you know, things aren't working in spite of, but create something that's efficient so it works along with everything else. Because, I mean, you throw enough boost at a diesel truck, it's going to make a ton of power. It's going to go fast, it's going to make a bunch of torque, and to a certain point, it's like guys operate on it, if it ain't broke, don't fix it. So unless it's making more power, or it's something that's going to break less as far as engine components, transmission components, guys are still running a lot of older tech and older parts in certain aspects of their build. So I mean, that's where Gabby and EIC came in. The flow bench data, his practical knowledge. This is a guy that designs cylinder heads from ground up, call it bespoke per application. I mean, his incredible knowledge as an engineer and his work in motorsports, and his background, it's for him to even take a moment out of his time to have a conversation with me, much less, you know, give me the one-on-one and the ability to use his equipment to kind of test some of these ideas that I get from other guys that are, you know, well knowledgeable in their fields. But it's like I get guys that have worked with a lot of incredible fuel and injection companies that lent me a lot of their knowledge as well, as far as how to implement it. It's not that I'm saying I designed something or came up with something that's perfect. I just wanted to get something that was as efficient as possible, so that it makes as much power and it's something unique that's coming from my brand. So as far as that, I mean, the first step here, if you guys want to take a look, I'm actually wrapping up the third design right here, which is the H22 intake manifold. All of these are configured as dual injectors. So you can see I still got a little bit of fine tuning on the tool pass, but I've been working on this one all week. It's pretty much wrapped up, ready to go. Just basically, I'm just making it look pretty now. You know, you get it to work, get the machine not to crash, don't cost you any serious money. Figure out what changes in tools go as far as speeds and feeds on the machine, so you get the results that you want. And this is like 98%. So by the end of the day, this thing will be completely done. But there's a bunch more that I'm going to show you, but there's a couple things that I need to go and take care of. So if you want to just hang out with me for a little bit, we'll get to it. I'll show you what I've been working on as far as the design goes. I mean, it's a lot of multitasking, a lot of different applications, a lot of customizing G-code so I don't kill my machine. But as you can see, this is the H that's out there right now. That's the base design. Dual runners, they are curved. So what that does is it's going to allow you to clear your lower transmission bracket. Stack heights and things we played with, mounting surface for the gasket, is actually wider than the original design. Should help eliminate any leaks for boost or vacuum over time. And also by making that area thicker and bringing all of the bolt holes internal, it's a little bit cleaner. And also we were able to increase where right now we're running, what is it? We got 5, 10, we have 16 bolts holding the plenum down. So I mean, tensile strength, holding power, it's there. That's one of the unique things that I did want. Some of the guys just had a couple times, you know, they might end up over time, because not everybody always does, you know, a nut and bolt on their car, like a road race car after every event. So sometimes you'll be third round eliminations and you get a boost leak because a couple of your bolts backed out. I've seen guys weld their pieces together. I mean, the only issue when you weld something together, if you do grenade a motor, it's a little bit more detailed as far as when you're trying to clean out debris out of your intake manifold, because you can't separate everything. So we wanted the ability to make it as easy to clean in those instances, while also making it as secure as far as holding everything together without having any leaks. All right, so for everyone that's been following along on the channel, I want to thank you and appreciate everything you've done to support us. For all of those who haven't already done so, make sure to hit the follow button, subscribe to the channel, and follow us on all the socials. Make sure you stay up to date on all of the newest projects, all the details that we have coming. Appreciate it, and make sure to hit the alert button in case I forgot to tell you that. So now we're gonna go and follow up with the rest of the product line and show you what we got going on. So what's happening is you have this original configuration, like we said before, and the way how this came about, like I said, uses a full set of billet runners that are actually lipped in and nested in for ease of welding. So guys were able to put this together to run 8 injectors side by side on the plenum, and use a ultra plenum that was a direct fit to the base. Singular rail. Couple things that we're doing on the one piece, we're going with a larger bore rail, so a little bit more volume. The injectors are still there. The injectors are still at the same angle. So the one thing we did want to maintain is we didn't want the injector spraying at the floor. By keeping the injection angle, even though you have to kind of alter it from Honda's original, keeping it as close to that provides that you get much better atomization at low speed air. So while the car's cruising around or idling, it's a lot easier to deal with. You play with your fuel trims on your tune. So it's not always about just an all-out drag car. 90% of my products end up on street cars, so I still have to build everything for the street car guys in mind. And so that's one of the things we definitely aim to maintain, was the injection angle. But as you can see, this is the original base of what this thing started out as. So let me see if I can flip this and not. So now that everything is one piece, the one thing that I did was I made the runners curved, so it adds for better clearance. It's easier for plumbing, charge piping, whether it be on a K series or a B series or H series manifold configuration. That wasn't something on my older equipment that I was even willing to attempt. Even though I could have, it would have driven the cost up trying to do that. One of the issues with that is depending on the angle the engine is mounted at, on the front wheel drive cars, if you're running the spacers and such like that with straight runners, usually your plenum ends up hitting the bottom of the hood. So most guys opted against that. Unless they went with like a lean mount, at that point the motor would come down, so it was a lot easier on the K series. So the curve runner was definitely something that was mandatory on the new configuration, because that's one of the things I wanted to eliminate. Now I'm gonna go and get out of the way so that you guys can see everything that's behind me clearly, and go over all of the final testing and values and everything, that how I came up with this current iteration. All right, now earlier in the video, you guys saw what was going on with our testing over at EIC with Gabby, and you're probably wondering exactly what I was doing, what I was trying to accomplish. Well, what I did was I used my trusty 3D printer here to save me, probably a couple grand in aluminum to actually refine the runner design and the inlet radiuses or fillets. Now, all of these prints, as you can see, there's actually more than what you see here. Because some of the stuff that we found that worked well on the first session of testing, we kind of combined certain elements with the recommendation that Gabby gave, and then printed some more with those revisions, went back and tested them just to do the verification. So some of the things that went about just trying to figure out what was going to generate the highest amount of CFM, we actually tested those on both ends, plenum side and runner side, to maximize. I mean, it's not an end all because it's just really giving us a refined, repetitive, controlled testing environment to see how one thing compares to the other. Because if you can verify that, then those results should transition in real world physics and applications, which a lot of this airflow stuff, I'll be honest with you, like I said, it's not my forte. The thing is, I can make a good part, I can work CAD designs, I can program and run my machines, which is something all of you guys know that's what I do. I run this entire operation by myself. As stressful as it is, it's enjoyable because I get to do things that most other people don't get to do on a regular basis. And I have fun doing it, 98% of the time. But like some of the things that we tested were actual, like the full fillet. So we could go with a full radius style, floor style, compound radiuses on the floor, single radiuses on the floor. We test different radius diameters, basically to figure out which ones generated the most amount of velocity and flow. Also, some of the things that we were able to test was just floor finish. Believe it or not, it's like, think of it this way. If you rub your hands together, they get warm. That's friction. There's also air friction. The odds of you reducing overall intake air temps, if you can keep the flow from really sticking against your walls as much as possible, that's going to reduce air friction. Reduce air friction also helps to lower intake air temps. Lower intake air temps leads to increased power and reliability, helps you fight off detonation. And a lot of that is why you see most guys are familiar with like just, standardized porting, where you, certain areas you want to leave semi-rough to help with atomization. Well, I mean, if you make everything super smooth, believe it or not, you will end up increasing the friction because your air can run more smoothly against an entire surface, which your IATs are going to go up. So some of the stuff that we played with that guys actually were able to test on some of the, like the first beta tests on some of the runs, were some of the floor finishes. So there's certain things like that, as well as the stack height, which is basically the velocity stack area, how far off of the floor it actually is. Because when you look at these things, we went from 10, 15, 20, 25 millimeters to test those. Believe it or not, the height of those off of the floor lends a lot to airflow. So we got those dialed in. I was able to change the shape, the ID shape of the runners, because that's easy to shape and manipulate, and then just go and print and just retest to get the most ideal shape. The exterior point A to point B was already predetermined because the runner length, I already knew what worked from all of the other DIY kits that we've gotten and what I wanted to stick to. So that, that aspect of the original DIY aided in designing runner length. The other accommodations that we did were just surface finishes. I mean, the radiuses, like we said, the shape actually helped with velocity. I mean, trying to go back in 3D machine another entire manifold to test it would have cost a lot of money. So the 3D prints that you saw us test, I mean, it was the easiest, most affordable way to consider saving costs as far as R&D goes. So this is tested and proven in a controlled environment, as you guys can see. Plenum shape, it's kind of standardized. There's a couple changes that you might see, which is you'll notice that the back plate isn't flat like how the DIY was set up. It is actually more bowl shaped. It increases the plenum volume overall. So that helped right there, because the higher power guys needed a little bit more volume. We kind of settled in with you know, a standardized volume that'll work for a lot of guys, to be honest with you. From there, the rest was just chasing a really nice finish on the product, inside and out. The throttle body flanges are standardized 90 millimeters Ford style, so that's pretty much what all of the major manufacturers are going to be using. So you'll be able to put on AccuFab, K-Tune, Skunk, anything that's a standard Ford style bolt pattern for a 90 mil. The rest of it, we kept with the original. We like the modular type setup configuration. We're going to do a couple, when I say we, I mean me. I'm going to do a couple different variations for like rear wheel drive specific, which those guys don't need as much angles. Typically those motors are mounted vertically or at a slight lean, so I will have a rear wheel drive specific only on launch, and these things, like I said, I've already went ahead and hit production, so it's great there. As you can see, went with something a little cleaner. Now some of this stuff became quite difficult to deal with as far as machining, so there are certain concessions I had to make as far as the machining process, because it's like why the other one was multi-piece, it was just honestly a lot easier to make multiple pieces versus just trying to do something as simple as, hey, I'm going to try to clear to do these injectors, but I have to get a tool past this large plenum base all the way down here. So you end up with, on the 5-axis, a part that's tilted like that and a really, really long tool trying to get all the way down. So there's certain things that made it not difficult, but just made it where it wasn't super easy, but I really wasn't trying to compromise the design. I'd rather just have a product that takes me, 7-8 hours to get out of the machine, but it's truer to the original design concept. So these things right now are ready to go. B series, K series, as well as the H that I showed you already. I'll be working on a couple other applications, but honestly, I got some other products that I've wrapping up R&D on. So it'll probably be a couple more months before the other applications, but I figured this covers the vast majority of the guys, especially the H guys, because I know the H22 crew, they need some love. The DIY guys, that was always very popular, man. K series and H was super popular. So I appreciate you guys checking out the new release of the intake manifold kits. These are full billet, modular setups, and make sure that you follow along, because we got more coming, and everybody's really gonna be surprised at the total price at where these things fall in line with the rest that's on the market. So I appreciate you paying attention to the journey, the development, all of the science that went along with this, and see that it was a full-fledged developed item. And go ahead and check it out, man. It's an incredible new product, and this is probably about 2 to 3 years getting to the point where I was ready to actually make the transition and release these things for you. So I know you like the video, and the only way to keep them coming is to follow along, like, and subscribe, and hit the bell, man, because these things, we got a ton of more stuff for the Honda guys, the JZ guys, and of course, we got some other platforms coming along later on this year. So thank you again, and hit the bell.